So we'll start a new video. It's about pipes. First, we need to discuss carbon steel pipes. Its carbon content significance, and significant means how carbon content influence strength, malleability, ductility, etc. Why CS pipes preferred over DI pipes. How stainless steel pipe are become non-corrosive. How CS pipes are manufactured. How GRP pipes are graded. How ERW method different from other methods, how DI pipes are manufactured, how DI pipes are graded, how SS pipes are manufactured, how DI pipes are graded, etc. SS pipes are graded, uh, how HDPE pipes are manufactured, how they are graded, how GRP pipes are manufactured and are they graded. How is GRE pipes different from GRP pipes? And how pipes joints are joined, our pipes are joined, etc. Now, for the second one, what is the difference in the codes that we are going to discuss now? Huh? So, what is the difference between these codes: API 5L, ASTM A106, ASME 31.3, and the API 1104? So API 5L and ASTM A106 are material specification for pipes. ASME B31.3 is a design and construction code for process piping, and API 1104 is the standard specifically for welding pipelines. So here is a breakdown. So we'll send it in detail. API 5L is the material specification. It is the pipeline transportation system in the petroleum and natural gas industries, like a long distance transport of gas, oil, water, etc. It covers both seamless and varied types of welded pipes, ERW, LSAW, etc. It offers a wide range of strength grades from A, B, X52 to X80, and two product specification levels, PSL1 and PSL2. ASTM. So, what is our API file grades and welding? So, ASTM A106. It is also material specification. It is for seamless pipe, CS pipe for high temperature and high pressure vessels like power plants, boilers, refineries, etc. It only applies to the seamless pipes available in three grades A, B, and C, with grade being the most common. Focus on the performance stability in the high temperature environments. ASME B31.3, it is for design and construction code of the pipes. It process piping system. Application is process piping system, chemical, petroleum, refinery, power generation, etc. It provides rules for the design, materials, fabrication, installation, inspection, and testing of the piping systems. It references the material specifications like ASTM A106, this one, for appropriate application. So, what is API 1104? It is a welding standard for the pipelines and the related facilities. It especially details the procedures, requirements for the welding pipelines, including NDT methods and the welder qualifications. It's also used in conjunction with the API 5L in the pipeline projects. So, summary. Both API 5L And the ASTM A106 defines the properties like a chemical, mechanical, manufacturing process, testing or requirements of actual pipe material itself. We can select a pipe that meets one of the standards like a API 5L grade B pipes. That is an example. So ASME B31.3 is an engineering code. It details how to design, build a whole piping system, including aspects like wall thickness, support design, component selection, etc. It specifies which materials like are suitable for certain temperature and pressure conditions, like A106 grade 3 for which kind of temperature and pressure, like that. And the API 1104 is a workmanship standard for welding. It provides guidelines for performing and inspecting welds on pipelines. It ensures an integrity of the joints. In short, a project might use API 5L designed pipe designed according to the ASME 31.3 and welding performed and inspected according to the API 1104 standards. Now, we saw which kind of pipe we have used according to this one. Okay. So finally, the difference are API 5 and A10 ASTM A106 define properties, manufacturing process and testing requirements of and ASTM B31 is an engineering code that indicates how to design and build a whole piping system like wall thickness calculation, support design, component selection. It specifies which material are suitable for certain temperature and pressure applications. APA 1104 is the workmanship standard for welding, provides guidelines for performing and inspecting welds on pipelines, ensuring integrity of the joints. So short is a user API 5L designated for ASME B31.3 code with the welding performed and inspected according to the API 1104 standards. Now, why is ASME B31.3 and not 31.4? So, uh, the the pipe grade steel pipe grade we uses uh, API 5L X52 PSL2 that we are going to discuss. We have the size from DN 800 to 900, 1200 and 1600. Okay. So this API 5L X52 is equivalent to ASTM A1024 pipes and ASTM A1024M. It is equivalent to ISO 3183 L360 also. What is ASME American Society of Mechanical Engineers and ASTM is American Society of Testing and Materials. These ASTM standards cover specification for carbon steel, welder and seamless pipes. It can be considered equivalent to API 5L X52 in terms of material properties and applications. This is the ISO standard equivalent to API 5L X52 3183 L360. So before moving on with the slides, we need to find out what is this API 5L. This one, API 5L X52 and why it is used in our project. Okay. API 5L grade X52 is commonly used for water transmission line. It's written in the API 5L01. Here, why it is commonly used? Because it provides enough strength for medium to high pressure water transmission line. But like 20 to 80 bar but while it can avoid also brittle behavior of other kind of pipes like X50 and X80 higher grades are stronger but are more expensive and harder to weld and also brittle. So avoid this brittle behavior and hardness in the welding. We are using this X52 grade pipes, but X52 means 50,000 psi pounds per square inch. That is converted into 360 MPa. അത് കുഴപ്പമില്ല. So that is the this minimum specified minimum yield strength is 360 MPa. More than that yield strength is there. What happens? Brittleness will come, and but we require this one only for getting this enough strength for to medium to high pressure water transmission lines. So tensile strength also for 66,000 to 110,000 psi, that is for 55 to 760 MPa, almost double. So yield strength and tensile strength. Yield strength, tensile is almost double than this yield strength. Adequate for hoof stress and surge pressure resistance. So yield stress is coming in the high pressure water transmission, but tensile strength is one who um, uh, um, resist hoof stress and surge pressure resistance. So yield strength versus ultimate tensile strength ratio is 0.93. So yield strength is always less than the 0.93. So it is less than 0.93 ensures ductility and energy absorption under transit loads. So it is for PSL2. So for to ensure ductility and energy absorption under transit loads, YS to UTS, that is yield strength to ultimate tensile strength, should be less than 0.93. So why X52? Simply saying higher grades are stronger but more expensive, harder to weld. Lower grades like a B or X40 require thicker walls for the same pressure, increasing the material handling cost. So design compatibility, we are always using Barlow's equation for hoof stress. That is a PD is equal to 2 FST. F means yield strength. F is a design factor. This is yield stress. So P means design pressure into D is this force is resisted by yield stress into T. So rearranging, we get T is equal to P into D by 2 into F is into S into F. T into S is equal to P into D. P into D. is divided by 2F. That is Barlow's law. So wall thickness, design pressure, D is equal to diameter OD, outside diameter, and S equal to S equal to minimum specified minimum yield stress. Specified minimum yield stress, design factor, typically 0.5 to 0.72. For 600 mm diameter OD, 25 bar pressure, X52, S equal to 360 MPa, F is equal to 0.6, T is equal to 3.47 mm. Rounded 6 mm for corrosion and allowance. Economical wall disc can compare to X42 or X50. So if it is X4, it was X42, it will become 4.3 mm, or if it is X50, it was going to 3 mm. So it is economical to change because in between. So that is design compatibility. Weldability. Carbon equivalent of X50 is 0.43, is greater than 0.43, less than 0.43, or 0.25 PCM. So allow for manual SMAW, GTAW automatic welding without preheat greater than 100 degrees Celsius. Low hydrogen cracking risk compared to high grades of X55 or N X70. Availability and fabrication. Most mills globally stock API 5L X52, globally stock X52 PSL1 and PSL2 in diameters. It is more available like X52 PSL1 and PSL2 are up to 60 inches already stocked. Common for seamless ERW or SAW production. Pipe coating, 3LPE, FBE, cement mortar lining easily compatible. Corrosion resistance and coating compatibility. Steel chemistry ensures good compatibility with that is carbon is less than 28.28% and manganese is less than 1.4%. So this is compatible with the fusion bonded epoxy, 3-layer polyethylene and cement mortar lining for potable water. Smooth surface and mechanical integrity ideal for internal lining adhesion. Design pressure at surge margins. For typical waterproof 100 to 80 bar, X52 offers 2 into factor of safety under surge water hammer, satisfy ISO 3184 API 5L and AWA C20 performance envelopes. Economic and logistic advantages. Optimal cost to performance ratio in the X grade spectrum. Easier forming and bending and welding on site. Thinner walls means lower transportation weight and field handling costs. Applicable standards means standards of AWA C8 ISO 3183 and ASME 31.4 and 31.5 pipeline design. Accepted material for portable industrial and irrigation water systems. So in summary, X50 is chosen for its strength, ductility, 360 MPa for SMYS means a specified minimum yield strength, or 52,000 PSI. Ductility is excellent, weldability is excellent, then it's low carbon equivalent. Corrosion compatibility high, availability is global standard, cost is economical vs higher grades, suitability ideal for uh, 10 to 80 bars with the water systems. So before moving, we need to find out what are the different grades available for carbon steel pipes. Now we'll discuss different grades of carbon steel pipes. It is based on ASTM, API and EN. Common examples are ASTM A106 grades A, B and C and API 5L grades, 5L grades and X series. So these degrees are based on mechanical properties like strength and corrosion resistance. It is determined by their chemical composition. Higher grades generally offering better performance. So we are interested in ASTM A106. It is available in grades A, B and C. Grade C is stronger than B and B is stronger than A. So American Petroleum Institute standards API 5L used for pipelines includes a range of grades from A and B up to the higher strength X grades like X42, 52, X70, etc. The number in the grade indicates a minimum yield strength, specified minimum yield strength in thousands of pounds per square inch. This X52 means 52,000 PSI. There are other standards classified pipes into grades such as P195 TR1, P235 TR1, P265 TR1, etc. Higher numbers indicate better strength and corrosion resistance. There are Chinese standards also uses grades like Q195, Q225, Q345. Similar to the other standards, higher grade means better performance. So how are these grades determined? Is based on their chemical composition and resulting mechanical properties like tensile strength, yield strength, and hardness. Higher grades like the ASTM A106 grade C compared to B typically have higher minimum tensile strength. Appropriate grade may be selected based on a specific application, considering factors like operating pressure, temperature, corrosive environment, etc. So we will now discuss what is a schedule mentioned in our schedule number mentioned in our pipes. Okay, what is a scheduled number of pipes? So schedule number is a number which indicates thickness of its walls, with large higher numbers signifying higher walls and greater pressure resistance. This is a dimensionless value. So the scheduled number actually it indicates a pipe's wall thickness. As a scheduled number increases, wall thickness also increases. The primary purpose of the pipes is to transfer fluids under pressure. To safely withstand this pressure, pipe must possess sufficient strength to fulfill their intended function without failure. So wall thickness is a very critical factor. It directly impacts pipe strength. Specification and based on as ASME B36.1 or for the seamless wrought steel pipe and ASME B36.19 for stainless steel pipe. Okay. So this pipe schedule, even though they have same outside diameter, they may have different schedule numbers. schedule 40, schedule 80, schedule 160, etc. So different wall thickness, but the outside diameter remains same. So schedule 5 means schedule 5S. This S means stainless steel. So schedule 10S, 20, 20S, 30, 40S, 80S, schedule 100, schedule 120, 140 and 160. Okay. So for a given pipe size, larger schedule number indicates a thicker pipe wall and smaller in the diameter, and for a given pipe size, a smaller schedule number indicates a thinner pipe wall and a larger inner diameter. Like NPS 3 schedule means OD is 3.5. It's also schedule 5 and schedule 80, but OD remains the same 3.5 inch, but thickness is increasing. Uh, Thickness is 0.08 in the schedule 5 and thickness is zero point 0.3 for the schedule 80. Okay. So an example calculation of schedule number. It is based on Barlow's wall thickness formula. So schedule number formula is 1000 into P by S, where P is the service pressure in PSI and S is the allowable stress in PSI. So if it is for an example, if it is the 480 psi and allowable stress value is 12,000 psi, then the pipe schedule can be calculated by this by substituting P is equal 480 and S equals 180, 12,000, and what will happen when so what we'll calculate? We'll cut this one. Cut this 2 will be cut. 48 means 6 into 8, 8, it is 6 into 2, 2 is cut, this is cut, this is cut, this is cut, 4. So 4 into 10 is 40 SCH. Okay. So this is the steel pipe. My God, we'll download it anyway. So these are the steel pipe dimension chart as per BSN 36.1. Here we know that we need as per this one uh, we need a schedule 40 schedule. So we go to schedule 40. So we want our pipe diameter is 1200. For schedule 40 we require what? We require 9.53 as the uh, wall thickness in millimeter. So this is how we are calculating this wall thickness. So we will download it and keep it. We are using the schedule number to calculate the wall thickness because outside diameter always is the same. Okay. Now, see, so when we saying that 1200, our NPS, this is the NPS value. This is 48. So we will check. So we can see here that 48 inch NPS. If NPS is 48, this outside diameter will be 1219. This is exactly shown here. If it is 48, our 1219 is the outside diameter. So we'll download this one for future reference. So that's all for our field schedule, schedule number. Then we go further with the difference in the ASME B31.3 and the 36.4 and the 31.8. Okay. Okay, we will discuss that in our next video. Thank you.